let's start by looking at how most of the Internet of Things applications, especially in consumer IoT, are being built today. So if you look at the IoT application people are familiar with, like connected personal devices, most of those are built around the so-called cloud-centric paradigm or around cloud-centric architecture. What does that mean? Well, the underlying assumption is that you have devices. This device push data toward the cloud. Within this cloud, you have analytics. These analytics make any kind of decision, take business intelligence, all the sort of things that we all want to do with IoT, and eventually push decision or action toward the edge. With the provision that the forecast that say that the number of sensors is going to grow to 50 billion by 2020, this cloud-centric architecture will be put under pressure. If you think for a few minutes about it, you will realize that one of the underlying assumptions is that devices are always connected, or at least connected most of the time. Because otherwise, if you're not connected, you cannot push data to the cloud, nor you can be controlled by the cloud. And that connectivity assumption doesn't hold true for several different IoT applications, most notably, let's say, in industrial Internet of Things. So you can imagine a car being able to easily connect to a cloud when driving downtown London or downtown Paris. But how about you riding on the Alps? All of a sudden, connectivity to the cloud might become a challenge. Another assumption that underlines and underpins the applicability of cloud-centric architecture is that you have always enough bandwidth to push data to the cloud. But if for a moment you think about smart grids or smart factories, those systems can produce up to half a terabyte of data per day. So imagine pushing all the data to the cloud. That is not going to work. Another assumption that underlines cloud-centric architecture, which doesn't always hold true in IoT in general, and that assumption is that the reaction time of the latency involved in sending the data to the cloud, taking the time to execute your analytics, and eventually pushing back the data to the edge to actuate your decision is compatible with the dynamics of your system. If you think about autonomous vehicles driving several tens of miles per hour side by side, how can you ever imagine that you can control the vehicle from a cloud? So how can you ever imagine to relegate all the decision about these kind of systems to a cloud? Well, it's just not possible. But that is not it, because there are some other challenges or some other preconditions that underlie the applicability of cloud-centric architecture. And that is, for instance, latency. So all of a sudden, you're assuming that the time required for data to go from a device to the cloud, be elaborated by analytics, and then eventually be pushed back to the edge is compatible with the dynamics of your system. And again, that might be true for some consumer Internet of Things application, but it's definitely not true from industrial Internet of Things application, such as those that you can find in smart grids, smart energy, or once again, autonomous vehicle. So obviously, we need more intelligence on the edge and more control on the edge. I think we will see a combination of an emerging paradigm called fog computing, or initially combined with cloud computing, in some instances perhaps deployed as just the single paradigm, and eventually there will be a blending of fog and cloud computing into just one fluid computing fabric that can address properly the edge requirement and the data center or typical data center requirements. So in essence, there won't be any IoT at scale without fog computing.